Welcome to Lecture 2. In Module 1, we covered the architecture and the agent loop. Now we ship the entire stack as one self-contained Helm chart. One Helm release, one namespace, 10 pods. From clean Kubernetes cluster to running agent in under a minute. The promise is simple. Every component, every credential, every connection wired in version-controlled YAML. No notebook drift, no clicking through Cloud Console wizards. Anyone on the team runs the same Helm install command and gets the same stack. The course's value lives in the chart itself, not in tribal knowledge. In the next 2 slides, you'll see the chart's anatomy and one of the 4 real operational gotchas that wasted real engineering hours when we built this. The kind of thing no documentation warned us about. Then you'll know exactly what kind of work this chart hides from you. Here's the chart anatomy. 14 templates plus 1 external dependency. Top of the diagram, chart.yaml and values.yaml. Environment-specific values, 1 file per cluster. Then the templates folder. The templates fall into clear groups. First, the data layer. Postgres for relational state. Minio for S3 compatible storage. QDRANT for the vector database, then the machine learning layer, MLflow for tracking, and the model registry, text embeddings inference, TEI, for converting text to vectors. Next, the agent layer, Unity Catalog open source for the table catalog, the 2 MCP servers, that's Model Context Protocol, that expose tools to the agent over HTTP, the agent service itself, Fast API plus LangGraph, and the Knowledge Assistant frontend. Finally, the operational glue, a namespace template, RBAC roles and bindings, config maps for non-sensitive configuration, secrets for credentials, an evaluation cron job that runs nightly, and one ingress for external access. The only external dependency is the Spark operator subchart, pulled from its upstream repository. Everything else lives in this single repo, version controlled together. Every value, every connection, every credential reference. Helm install, done. Now the gotcha that bit us during the build, the gotcha. MLflow without Psycho PG2. The official MLflow Docker image does not ship with the Postgres driver. Many production guides tell you to add an init-container that runs MLflow DB upgrade before the server starts. Sounds clean. Init-container migrates the schema, then the server boots. The problem is subtle. On a fresh Postgres database, MLflow DB upgrade also fails. The migration scripts assume the schema already exists, so the init-container errors out, the deployment never moves past init, and your MLflow pod is permanently stuck in crash loop back off. Here's the fix. Drop the init-container entirely. Configure the MLflow server with the Postgres connection string and let it bootstrap its own schema on first start. The server has create table privileges and will set up the tables it needs the moment it boots. No init container, no migration race, no forked image. Set memory limits on the MLflow pod. The default is unbounded, and the server will happily consume all node memory while loading large model registry runs. We set resources.limits.memory to 2 GB. Adjust to your workload. That's one of 4 operational gotchas the chart absorbs. The chart anatomy you saw a slide ago contains all 4 prefixed. You install it. You move on. In Module 3, we wire the actual agent code to the stack. See you there.